Now, what about programmable objects? Redshift, like most relational databases, permit the creation of programmable objects known as functions, or user-defined functions. Something that Redshift inherited from its Postgres ancestors is the ability to write those functions in either the SQL language or Python. Leveraging the power of Python gives you all kinds of options and power. Internal performance of Python code is outside the scope of this course, but when using any user-defined function, it's important to know how often a specific function is going to be called in a specific query or algorithm or approach. Say, for example, you put a function into the predicate of a query that needs to scan an entire table. Look at this query sample here as an example. That function, being a predicate, is going to be called once for every row that's analyzed in the table to see if it meets that predicate. Considering that Redshift is a petabyte scale data warehouse, that's potentially billions of times for a single query. Thinking exponentially like this should reinforce the behavior of writing simple, effective, high-performance functions that are used sparingly and, above all, are completely avoided, if at all possible, when used in predicates. Views, another programmable object, can have the same benefit and risk. It's important to remember that a view is not a physical storage object of data. Really what it is simply a stored select statement. So in other words, it allows the reduction of complex logic for individual queries that can leverage pre-written data sets. But whatever performance impact exists against that view is going to carry over to any query that references that view. And if you do something like a complex CTE or a complex set of joins, again, this view can become exponential. So when it comes to designing views that are used heavily, ensure that the manner in which that view is designed is best practice and high performance. Now, of course, all of this is within a perfect world. Sometimes you have to write code and use functions in predicates. But knowing the performance impact that these can have can keep you from doing it when it's unnecessary. Now, we'll talk a lot more about designing queries for high performance, and this will have an effect on how you design views in another module. Another object that's common in database development is temp tables. Temp tables can become an extremely useful tool in the hands of a good developer. There are often intermediate data sets needed for only a short amount of time that are better managed as a physical data set as opposed to a logical query result, especially when needed across different sessions. So a good best practice to follow when creating temp tables is take the time to consider the makeup of these tables just like you would a permanent table. When dealing with the data sizes that Redshift can support, these temp tables are often not trivial. There are multiple ways to create temp tables, such as the select into statement, the create temporary table as, or using traditional create table syntax. The last option is going to give you the most control over selecting distribution styles, compression encodings, and specific data types. The first one, for example, select into, gives you almost no control. You're going to be stuck with default choices of data types, and then the distribution style is going to be even, no matter what would actually be best for this storage of data. So when it comes to creating temp tables, don't take the easy way out. If at all possible, think your temp table through, and then design your code to be explicit about what it requires to actually be high performance.